Imagine you're visiting a pet store, admiring a tank full of colorful fish. A staff member is asked to catch a specific type of fish for you. They use a net, but without much care, they scoop other fish along with the one they intended to catch. The staff member chose the right tool, a net, but used it inefficiently. They must now spend extra time returning the fish they unintentionally caught to the tank and try again. In coding, catching exceptions is like using that net. When you write catch blocks, you are handling exceptions in your code. But if you're not careful, you might catch more than you intended. This brings us to the concept of catch-all exceptions. While the name might suggest that catching all exceptions is a good thing, it's actually something we want to avoid. Just like in the pet store, where you don't want to catch all the fish, in coding, you don't want to catch every possible exception indiscriminately. This video will help you understand what catch-all exceptions are and why it's important to avoid them. By the end of this video, you'll know how to write more efficient and clean code. Let's get started. You already know that Java's error and exception classes form a hierarchy. Here's a reminder of their hierarchy. The parent or superclass at the topmost level is throwable. Both error and exception are direct subclasses of throwable. The hierarchy is extensive, with many subclasses branching out from the main error and exception categories. For example, under error, you have specific errors like out-of-memory error and stack overflow error, which signal serious issues within the Java virtual machine. On the other side, under exception, you find more granular subclasses like file not found exception under I/O exception or arithmetic exception under runtime exception, which are more common in day-to-day coding. You can also download this diagram from the video resources if you wish to examine it more closely. When you are coding, your instinct may be to include a type high up in the diagram to catch everything that might come up in your net. If you catch generic types such as throwable and exception, you'll be catching all their subtypes of exceptions in a single catch block. It's like catching every type of fish in the net when you only want one specific type. Let's explore some examples. According to Java's exception hierarchy, throwable is the superclass of all exceptions and errors. Java allows you to use it in a catch block, but this is not recommended. Again, if you use a throwable in a catch block, there's a risk that your code will not only catch exceptions but also errors. You are not supposed to catch errors in your code. Errors are thrown by the Java virtual machine to indicate a serious problem exists, such as a stack overflow or an out-of-memory situation. Now, consider handling an arithmetic exception. If you specify the generic class exception in your catch block, you catch the arithmetic exception. But you also end up catching all other checked and unchecked exceptions. It's like catching every type of fish in the net when you only want to catch one goldfish. So how can you avoid these types of catch-all exceptions? What should you keep in mind? When creating exception handling code, avoid using throwable and exception as the exception class type in catch blocks. Instead, when handling unchecked exceptions, always try to find the class that best fits the exceptional event in your code. Finally, what should you do if you need to handle multiple exceptions in one try block? What would be the best practice? Place the catch block for the most specific exception in the try block first, followed by less specific ones. This helps ensure you only catch what you need to. In this video, you've explored what catch-all exceptions are, why they are a problem, and how to avoid them. Well done! As you continue developing code, remember to handle exceptions thoughtfully. Just like the staff member at the pet store who needed to focus on catching the right fish, you should aim to catch only the specific exceptions your code needs to handle. Doing so leads to smoother and more predictable outcomes.